A polygon is a two-dimensional closed shape with a minimum of 3 straight sides. They have several classifications based on the number of sides. And for that, we have triangles for 3-sided polygons, quadrilaterals for 4-sided polygons, pentagons for 5-sided polygons, hexagon for 6-sided polygons, heptagon for 7-sided polygons, octagon for 8-sided polygons, and so on. The next, convex polygons. The classification contains all polygons with an interior angle less than 180 degrees. Examples are rectangles, triangles, squares, pentagons, and so on. If you can relate to the fact that lines at 180 degrees to themselves form a straight line, you will understand that a lot of polygons fall under this category. Concave polygons. This classification contains all polygons with interior angles that are less than 180 degrees. Examples include the plus sign, the arrow sign, and the star sign. The next, regular polygons. All sides and all angles are equal, and they include squares, the equilateral triangle, and some others. Irregular polygon. Not all sides or interior angles are equal. A lot also falls under this category. We have the isosceles triangle, we have the right angle triangle, we have the rectangle. Quadrilaterals are 4-sided polygons. We have several kinds, which includes trapezoids. They have at least one pair of parallel sides. Then we have the parallelogram. Opposite sides are parallel and equal in length. We also have the rectangles. They are parallelograms with 4 right angles. We have the squares. They have 4 right angles and all 4 sides equal. The rhombus. It's a parallelogram with all 4 sides equal in length. We have the kites. They have 2 pairs of adjacent sides and they have all equal lengths. Let's look at theorems for interior and exterior angles of a polygon. The first one is that the sum of the interior angles of an n-sided convex polygon is 2n minus 4 right angles, or 180 n minus 2. 2n minus 4 right angles represents 2n minus 4 times 90 degrees, because the right angle is 90 degrees. Then the sum of exterior angles of any convex polygon is 4 right angles, which is 4 times 90 degrees, which is 360 degrees. Remember that these rules stand for convex polygons, and convex polygons are polygons that have all interior angles less than 180 degrees. Let's look at an exercise. The interior angle of a quadrilateral are x plus 15 degrees, 2x minus 45 degrees, x minus 30 degrees, x plus 10 degrees. Find the value of the least interior angle. The question is from JAM 2010. Now, we have a quadrilateral and we have the 4 interior angles. We're asked to find which of these 4 interior angles is the least angle. So the first thing we do is we find x, and then consequently we find the least angle. So we know that sum of interior angles of a quadrilateral equals 360 degrees, because from the theorems we just looked at, it was mentioned that the sum of the interior angles of a convex polygon is 180 times n minus 2. So n there stands for the number of sides. So if we have n minus 2, okay, that would be equivalent to 4 minus 2, which gives us 2. Okay, so if we're multiplying n minus 2 by 180, it means we're having 180 times 2, alright, which would give us 360. So we understand that the sum of interior angles of a quadrilateral is 360 degrees. Next, we sum up the angles we've been given: x plus 15 degrees plus 2x minus 45 degrees plus x minus 30 degrees plus x plus 10 degrees, and sum them equal to 360. Next, we open the brackets and we collect like terms, and when we do that, we have x plus 2x plus x degrees, and we have that adding to 15 minus 14 minus 30 plus 10 degrees. We now have 5x minus 50 degrees equal to 360. We make x the subject of formula. We have 360 plus 50 divided by 5, which gives us 82 degrees. So therefore, if our x is 82 degrees, the least angle will obviously be the angle that 30 is subtracted from, because every other one, we have x plus 15, then we also have x plus 10. The only other angle we have will be 2x minus 45, but if you multiply x by 2 and subtract 45 from it, it will still be greater than x minus 30. So x minus 30, even from a glance, is the least angle. That would give us 52 degrees. So triangles, we can classify them by their sides, and if we were to do that, then we would have the isosceles triangle, which is the triangle that has only two equal sides. We have the scalene triangle. It has all sides not equal in length, and even the angles are not equal. We have the equilateral triangle that has all three sides equal and all angles equal, and each of them has a value of 60 degrees because they all have to sum up to 180. We can also classify them by their angles. So we have the acute triangle, which has all three angles less than 90 degrees. We have the right angle triangle, which has one angle equal to 90 degrees. And we have the obtuse, which has one angle greater than 90 degrees. So theorems for interior and exterior angles of a triangle. The first one is the sum of angles in a triangle is 180 degrees. And we can see from this triangle we have a plus b plus c equals 180. Then the exterior angles of a triangle is equal to the sum of the opposite interior angle. We see that angle D is same as angle A plus B. And the idea behind this is sum of angles in a triangle is 180 degrees, and sum of angles on a straight line is also 180 degrees. So if D plus C is 180 degrees and A plus B plus C is 180 degrees, then means that D plus A plus B would give us 180, because D complements C and A plus B complements C to make 180. Three base angles of the isosceles triangle are equal. All angles of an equilateral triangle are equal and each equal to 60 degrees. Let's look at the parallelogram. Opposite sides and opposite angles of a parallelogram are equal. The diagonals of a parallelogram bisect each other. So from the picture we have, we can see that A0 equals 0C and B0 equals 0D, because those lines bisect themselves. Now let's remind ourselves of other very important rules in geometry. The first is the sum of angles in a straight line is 180, and we see that A plus B plus C plus D equals 180. Vertically opposite angles are equal. Alright, so we see A is equal to B, C is equal to D from the graphic. We have sum of angles at the point is 360 degrees, and we see that A plus C plus D plus B equals 360. Moving on, alternate angles are equal. So from this diagram we'll see we have A equal to B, D equal to C. But how do we spot alternate angles? For alternate angles to occur, we must have two parallel lines and a transversal. And a transversal is a line which passes through two or more lines. So we can see we have this line and this line parallel, and we have this line cutting through both lines, and this is the transversal. When we have that, the next thing we do is we look out for a Z shape. We can see that this is a Z shape, and we can have also a reverse Z shape like this. When we have this, we then spot the interior angles of that shape. So if we are considering this shape, we have this as an interior angle and this as an interior angle. and so these two interior angles are equal. And then if you're considering this shape, we have this as an interior angle and this as an interior angle, and so in that case these two angles are equal. So we have A equal to B, D equal to C. So two important things to look out for: parallel lines and the transversal, and then the Z shape. Next, we have corresponding angles are equal. In this case, we have A equal to B and D equal to C. Alright, so what are the things we look out for in this case? We look out for two parallel lines, a transversal, and in this case an F shape. So you can see that we have something like an F here. If we do have something like that, then we look out for where we have the exterior angle of the F shape and the interior angle this way. Those two angles are equal. This is the F shape I'm considering now. So A is equal to B. Then this interior angle C and the exterior angle D are both equal. Alright, so we have A equal to B, D equal to C, and these are called corresponding angles. One last one: if three or more parallel lines cut off equal intercepts on a transversal, then they cut off equal intercepts on any other transversal. I have talked about the transversal being a line that passes through two or more points, but here the idea is if we have 1, 2, 3 lines or more and they are parallel, just like these ones are, and we have one line that passes through them, and this line cuts off equal intercepts, that's DE. This line DE is equal to line EF. Alright, so we have equal intercepts here. It will automatically mean that any other line you draw that is a transversal to these other lines, however it passes, will form equal intercepts too. So we're going to also have AB, in this case AB equal to BC, and we can also have it in the reverse. If these three lines are parallel lines and we have this line cutting through it, okay, as long as AB equals BC, any other line drawn that passes through these three parallel lines will form equal intercepts. Let's do an exercise. In the diagram above, we have PQRS as a rhombus, and angle PSQ is 35 degrees. We're asked to calculate the size of angle PRQ. So the first thing we do, we look at the shape intelligently to find obvious angles we can without calculations, and then we use those angles to find PRQ. Okay, so first on our list we have that the diagonals of a rhombus or a square bisect each other. Okay, remember we talked about that for parallelograms, and of course this is one of them. Opposite sides are parallel and equal in length, so we have this as a parallelogram. But not only do they bisect themselves, but they bisect themselves at 90 degrees. So secondly, we have PSQ equal to SQR, and that will be because of alternate angles. And if we look closely, we'll see we have two parallel lines, this one and this one, and we have a transversal, which is this diagonal that connects both lines. So once we have that, we look out for our Z shape. We have this shape here, so automatically means this angle is equal to this angle, so that's PSQ and SQR. So we have alternate angles there. We have sum of angles in a triangle equals 180. So if we pick out this triangle, we have this angle as 35, and we know this angle as 90 degrees, of course, because we just said diagonals of a rhombus or square bisect each other at 90 degrees. So we have this as 90 degrees, so we can easily find this place using sum of angles in a triangle. Alright, so if we do that, we have 35 plus 90 plus PRQ equals 180. Of course, the angle we use here is PRQ. That's because even if we're looking for this value here, this value equals PRQ because of alternate angles. So this is equal to this. Alright, of course, because we have two parallel lines and a transversal also this way, and we can form our Z shape. So we have this angle equal to this angle, so we have 35 plus 90 plus PRQ, which is this angle, would give us 180. Okay, so moving on, we have 180 minus 35 plus 90, which would give us 55 degrees. So we have our angle PRQ as 55 degrees.